surroundings change.
Masa-masa ini lewati bersama, karya gemilang, karya prestasi. Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Karya gemilang, karya prestasi, pada aku langkah untuk maju. Sejarah baru. Mahasiswa.
Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia, dan alam
Distinguished guests, participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and welcome to the opening of the International Conference on Statistics and Data Science, ICSDS 2022. I would first like to introduce myself. My name is Azahra Rahmat, currently a final year student at IPB University, majoring in Statistics and Data Science, and I'll be your Master of Ceremony this morning. ICSDS 2022 aims to provide opportunities to connect and conduct scientific discussion between students, researchers, and professionals in the field of statistics and data science. In addition, ICSDS this year will bring the main topic of converting data into effective actions and will focus on several scopes, such as computational statistics, statistics for physics and chemistry, as well mathematical and statistical modeling. It is an honor for me to introduce and welcome our guests at our conference this morning. Welcome to the Director of IPB University, Professor Dr. Arif Satria. Welcome to the Honorable Dean Faculty of Mathematics and Natural Sciences, IPB University, Dr. Berry Juliandi SSC MSc. And also, we welcome President of Forum Pendidikan Tinggi Statistika Forstat Indonesia, Dr. Yudi Andriana. Also, we welcome Secretary General of Indonesian Statistician Association, ISI, Dr. Erni Triastuti MS. And all the head of department, in Faculty of Mathematics and Natural Sciences, IPB University. We also welcome all the presenters and participants from all over the world to the International Conference on Statistics and Data Science ICSDS 2022. We wish all of you good luck and may this conference prove insightful. For a brief moment, we would like to invite you to mute your microphone and sing to the Indonesian national anthem, Indonesia Raya. Thank you for listening to the Indonesian national anthem, Indonesia Raya. Now we would like to play a short video introducing the Department of Statistics, IPB University. We would like to invite you to mute your microphones and direct your attention to the video.
Departemen Statistika IPB menyelenggarakan pendidikan tinggi bidang statistika dan sains data untuk menyiapkan lulusan dengan kemampuan analitik dan komputasi yang mumpuni sehingga mampu bersaing baik pada level nasional maupun internasional. Lulusan Departemen Statistika IPB disiapkan untuk mampu menerjemahkan permasalahan nyata dalam suatu bidang ilmu ke dalam konteks statistika dan sebaliknya mampu menerjemahkan hasil analisis dan kesimpulan yang ditarik secara statistika ke dalam bidang ilmu yang bersangkutan, serta memiliki landasan yang kuat untuk mengembangkan keilmuan dan atau mengikuti pendidikan lanjut dalam bidang statistika atau bidang lain yang memerlukan penguasaan metode kuantitatif yang kuat.
Departemen Statistika IPB mempersiapkan kami, para mahasiswanya, untuk menjadi data scientist yang handal. Di Statistika IPB, kami diberikan bekal mengenai cara mengambil data, menganalisis, sampai menginterpretasikannya. Karena pada sejatinya, semua hal di dunia ini menggantung data. tak terkecuali hal terkecil sekalipun. Oleh karena itu, dengan kemampuan menganalisis data, maka berarti kami siap untuk bersaing di segala bidang. Statistika IPB, there is no statistics without variance.
Departemen Statistika IPB merupakan salah satu departemen terfavorit di Institut Pertanian Bogor. Menjadi bagian dari Departemen Statistika merupakan salah satu pencapaian terbaik dalam diri saya. Pembelajaran yang diberikan di Departemen Statistika terus mengalami pembaharuan seiring dengan berkembangnya zaman, khususnya di era Big Data. Lulusan statistik memiliki potensi tinggi memasuki dunia kerja, because statistik is a sexiest job.
That concludes the video profile of the Department of Statistics IPB University. The next agenda is opening remarks, which will be delivered by the chairman of the International Conference on Statistics and Data Science, ICSDS 2022, Dr. Farid Muhammad Afendi. We would like to invite Dr. Farid Muhammad Afendi to the screen. For Dr. Farid, you are kindly requested.
Thank you, Azhara. Assalamualaikum warahmatullahi wabarakatuh. Very good morning to everyone. To the Rector of IPB University, Professor Dr. Arif Satria, Dean, Faculty of Math and Natural Sciences, IPB University, Dr. Biri Juliandi, Head of Department of Statistics, IPB University, Dr. Anang Kurnia, Head of Department of Math, IPB, Dr. Endar Nugrahani, Head of Department of Computer Science, Dr. Soni Hartono Wijaya, Head of Department of Biology, IPB, Dr. Iman Rusmana, Head of Department of Chemistry, Professor Dr. Dia Iswantuni, Head of Department of Physics, IPB, Professor Dr. Tony Ibnu Sumaryada, Head of Department of Geophysics and Meteorology, Dr. Rahmat Hidayat, Head of Department of Biochemistry, Dr. Samsul Falah, Secretary General of Indonesian Statistical Association, Dr. Erni Tastuti, President of Forstat, Dr. Yudi Andriana, invited speakers, presenters, participants, lecturers, researchers, postgraduate students of the IPB University. With great pleasure, we would like to welcome you to the International Conference of Statistics and Data Science, ICSDS 2022. This event was held as a series of activities in the context of the IPB anniversary and also as a part of the National Statistics Day in Indonesia. The ICSDS 2022 aimed to engage researchers, fellow scientists, and academicians on the progress of their research in the areas of computational statistics and data science, theory and application of statistics in many areas, and also general statistical modeling. Session will consist of distinguished keynote speakers and parallel sessions, and we hope that the ICSDS 2022 will be a platform of communication for participants to further work together and collaborate in statistics-related research. In this ICSDS 2022, we have about 25 presenters, both local and international. The national presenters are from various countries such as Japan, South Korea, China, and United Kingdom. Besides invited speakers and presenters, we have also a few hundreds of academicians, researchers, and postgraduate and also undergraduate students joining the conference. All of us, the committee, presenters, participants, institution, and IPB University are very lucky because in this ICSDS 2022 and also last year actually, we have invited speakers who come from 5 continents, Africa, Europe, America, Australia, and also Asia. I want to express my sincere and deep gratitude to God, Almighty Allah, who make this conference happens. Thanks a lot to the Rector of IPB University for allowing us to host the conference, as well as to provide the financial support. Dean of Faculty of Mathematics and Natural Sciences, Head of Department of Statistics, Indonesian Statistical Association, Forstat, all participants, presenter, and invited speakers for making this event successful. Special thanks also to unforgettable all members of the organizing committee for their effort, hard work, and smart work in ensuring this success of this event. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Farid Muhammad Afendi, for the remarkable remarks. Having been introduced to the Department of Statistics, we will now watch another introductory video. This video will present a short introduction of our beloved IPB University. Please enjoy.
IPB University is transforming into an excellent higher education institution in agriculture, marine, and tropical biosciences. We're committed to strengthen the nation's dignity. We continue to move forward and become a leading university in Indonesia. Not only at the national level, we continue to challenge ourselves to be the best at the global level. IPB University currently has 9 faculties, offering 38 undergraduate programs, in addition to a School of Business and a School of Vocational College. To provide quality education and the best learning experience, IPB University pursues to advance both national and international accreditation and certification. Listed as the most prospective contributor of innovation in Indonesia, IPB University has research centers that facilitate research in various fields. By innovating perpetually, we can elaborate a sustainable quality of life. We breed youth entrepreneurs that drive the nation's independence in the future. We are aware of the magnitude of collaboration in fostering innovative mindset to continue growing and developing. IPB University have and will continue to collaborate with diverse partners domestically and globally. IPB University continually contribute at the global level. Immersed in consorts of international research and education development. IPB University is committed to continue to grow, brighten the nation's future through innovation. IPB University, inspiring innovation with integrity.
That concludes IPB University, our beloved university video introduction. And then the final agenda for this opening will be opening remarks from Dr. Arif Satria, SPMSI, as our Rector of IPB University. We would like to invite Professor Dr. Arif Satria, SPMSI, to the screen. For Professor Dr. Arif, you are kindly requested on the screen.
Assalamualaikum warahmatullahi wabarakatuh. Honorable President of Indonesian Statistical Association, Honorable Chairman of Forum Penyelenggaraan Pendidikan Tinggi Statistika, Honorable Dean of Faculty of Mathematics and Natural Science, Honorable of the Chairman of International Conference of Statistics and Data Science 2022, and Honorable all invited speakers and all participants. Ladies and gentlemen, ICSDS 2022 will be one of the most interesting conference in 2022, focusing on statistics and data science, converting data into effective actions. This event is organized to be a place for experts and practitioners of mathematics, statistics, analytics, and data science to meet for getting to know each other, to exchange ideas, and to collaborate toward the further development. We all know that information and knowledge are lying inside the data, and statistical and data science provide systematic methodologies to reveal those significant things. However, it may be not enough. We should be able to convert them to create good decisions. We should be able to convert information and knowledge to action that bring us in our organization to a higher level. The statistics and data science could guide us a lot of to achieve this issue, and I believe that Department of Statistics and Data Science is concerned with developing statistics and data science at IPB University. It is not only about the technology, but also changing our mindset so we can change our behavior. With so many data we already have, and we will have in the future, we need ways to utilize data or this new oil as optimal as possible to reach brighter future. The conference will provide unique opportunity, exchanging experience, sharing good ideas in field of statistics and data science in this 4.0 era. On behalf of IB University, I would like to express my sincere gratitude to all stakeholders, especially for the organizing committee who have been working hard to organize and review papers for this conference. Also, we would like to express our gratitude to moderator, invited speakers, and to all participants, last but not least, for your health and fruitful experience. By saying Bismillahirrahmanirrahim, the International Conference of Statistics and Data Science 2022, Statistics and Data Science Converting Data into Effective Action, officially open. I hope this conference will be successful and enjoyable event. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Arif Satria, for the brilliant opening speech. With the opening speech concludes that conference has officially been opened. And now, before we officially start the conference, we will have a photo session together. So in my screen, we have 5 pages on Zoom. So while waiting for the documentation team, please make sure you have your camera on and please be prepared. Okay, for the page 1, we will take a photo in 3, 2, 1. Okay, next for the page 2, and 3, 2, 1. Page 3, and 3, 2, 1. Page 4, and 3, 2, 1. Last but not least, for the page 5, in 3, 2, and 1. Okay, thank you for showing us your brightest smile. And yeah, ladies and gentlemen, let me first deliver a summary of today's agenda. In brief, we will have 2 plenary sessions followed by parallel session. Every plenary sessions will consist of 2 speakers and a Q&A session, while the parallel session will be conducted with moderators in each breakout rooms. We are honored to have Professor Hwan Seung-yong from Ihwa Women's University, South Korea, and Associate Professor Muhammad Altaf Ul Amin from Nara Institute of Science and Technology, Japan, in plenary session 1. And also, we are honored to have Professor Dr. Muhammad Nur Aidi from IPB University, Indonesia, and Associate Professor Dr. Epiredi Selim from Prince of Songkla, Thailand, in plenary session 2. As well, Dr. Anwar Fitrianto and Mrs. Dian Kusumaningrum as our moderators for the plenary session today. We are now continuing our meeting to the next agenda. That is a plenary session 1, which will be delivered by Professor Hwan Seung-yong from Ihwa Women's University, South Korea, and also Associate Professor Muhammad Altaf Ul Amin from Nara Institute of Science and Technology, Japan. The session will be moderated by Dr. Anwar Fitrianto. And for the CV itself, Dr. Anwar Fitrianto had his PhD in University Putra Malaysia and currently as a senior lecturer of IPB University and has experts in statistical modeling, statistical quality control, and also robust statistics. For Dr. Anwar Fitrianto, I'll give my screen to you.
Thank you very much, MC. Can you hear my voice? Hello, can you hear my voice?
Yes, I can hear.
Yeah, thank you very much, MC. So the next session will be a plenary session 1. So as it's said by the MC, that we will present two speakers today. The first one is Professor Huan Seung Young, and the second one is Prof. Altaf Ul Amin. Okay, thank you very much for attending this conference. So let me read a brief CV for the first speaker, who is Professor Huan Seung Young. So name is Huan Seung Young, date of birth January 28, 1961. Okay, so place of birth from Chuncheong, Gangwon Province, Korea. Then currently he is a professor at the Department of Computer Science and Engineering, EWHA, Women University, Korea. Then his education background, he got his BSc in the South National University in 1983, and then master degree in the Department of Computer Engineering, Seoul National University in 1985, and then he got his PhD from the Department of Computer Science, Seoul National University in 1994. So he will deliver quite interesting topics of his talk. That is from Homodeus to Robodeus. So you have around 30 minutes to present your talk. So time is yours, and then the Q&A session will be allocated in the end of the session. Thank you, and time is yours, Professor Seung Young.
Let me share. Oh, I want to share my slide.
Yes, please.
Yeah. Okay, can you see?
Yes, we can see your screen.
Can you see? Yeah, everybody.
Yes, yeah.
Okay, thank
Please.
you. Good morning, and it's very nice inviting me. My topic is from Homodeus to Robodeus. My talk is about artificial intelligence. Before I talk about AI, the computational thinking and problem-solving method is very important to South Korea. So we have a project to teach every student about the computational thinking and the problem-solving method. But now this topic is also important, and now the topic is a little changing to AI. But what is computational thinking? It's a problem, and many scholars think differently. There is no standard set of computational thinking, and also problem-solving method is important. But what is really problem-solving is also a problem. So to solve these issues, and we have to teach to every student in our university, and know right textbook. So last year, I wrote a book about this topic. Yeah. This is our country's trend.
Can you make your screen as a full screen? Your slide as a full screen?
Huh?
Can you make your slide as a full screen for us? So as the audience view, it is, I think, presenter view, Prof.
Are there any problem on my slide?
Yeah, actually, we see it quite small. So can you make it as a full screen so that it will be more clear, Prof?
Yeah. Okay. I'll show you again.
Click the slideshow option. No.
Yeah, the slideshow. Sorry for disturbing, Prof.
Okay. Maybe, yeah. Can you see
that's
the
great.
screen? Okay.
Thank you.
So I defined the 8 category of what is the computational thinking. This is the 8 category and some details. And this is the problem-solving method of I categorized 6 categories. Yeah. So algorithm, abstraction, analogy, divide and conquer, AI and knowledge, and the running is very important. So I separately categorize these issues. Yes, this is not perfect, but at first, I started to categorize these 2 problems. Okay, let's talk about AI. And what is AI is also a problem, because AI is from software, but nowadays everybody think differently. AI is different from software. What is different? In 1980s, AI's name is complex information processing. Yeah. But so recently, I think that AI is software. Yeah. This is different, really. Softer than software is my thinking, because software really is not software. Yeah, it's softer than hardware, but relatively soft. But software is really not soft, because when we have to modify software, it is very hard. But AI software is easy to modify, because AI have no application algorithm. Yeah, AI have only running strategies and apply the knowledge. So when we develop AI, we usually prefer only input data and output data. Yeah. So that's the difference of software and AI. So AI is really automatic programming solution. This solution is the idea of all programmers. Yeah, programmers do not want to program. Yeah, so I think this is the final solution to all software engineers. But AI requires knowledge, so we have to extract knowledge from data. That's the important issue. And also, there are many different kinds of intelligence. So I categorize the intelligence into 5. This is my my work, only my work. And so at first, existing normal software have an algorithm, and the algorithm is also a kind of intelligence. So this is the basic intelligence. I say soft intelligence, and some softwares use many data. Like navigation software. Navigation have a lot of map data and traffic data, etc. So I think navigation software intelligence, we can say data intelligence. This is the existing software, but this is data mining. This weak AI is a very right model is data mining, and data mining require feature extraction and running and data. Data mining is also an AI, but this is a little weak, and we usually say strong AI. But I wanted to categorize strong with super intelligence, and super intelligence means bit more than human intelligence. This strong AI is at the same level with human, but super intelligence means more than human. So, but the difference between strong and super intelligence, they all do not require feature extraction. And they all require, usually AI requires data, big data, but super intelligence, some super intelligence do not need any data. The example is AlphaZero. So everybody knows this is very strong impact to the human kind. AI changes all our future. And everybody say, COVID-19 accelerate the online. So we are now heading a conference internationally. This is the COVID give us a chance, and so we can share everybody. We can do every jobs through online. This I think 10 years. COVID accelerate more than 10 years change rapidly for humankind. But everybody also say AI will accelerate 100 times more than COVID-19. So in our country, digital transformation is a very hot topics. But now somebody say, not digital transformation, but AI transformation more important. So everybody have a question. Will AI dominate human? Will AI can have a mind? Also, will AI can have an emotion? Or AI can do creative work? And then how we can coexist with AI? This kind of question is a big question, and the answer is I'm thinking very positively. Yes, right. All can do. So AI. The conclusion. My conclusion is that AI will be a grand master of humans. That's my conclusion. So now, the super intelligence is already near, and robot technology is well developed, and so humanoid is also coming near to our life. And my conclusion is that humanoid will be a liberator to humans, because when AI is used in everywhere, Humans do not need to think anymore. Yeah, we do not need. Yeah, AI will think instead of me. It means until now, intelligence level determine the job of human. But I think because we do not need to think anymore, intelligence do not categorize people. Equalize power of people's intelligence. When we develop gun, then physical power is not important anymore. That's the same kind of thing. And also, humanoid will do all jobs instead of human. So humans do not need to work and labor. Yeah. So everybody say capitalism have a problem to create a labor class, but in the future, no labor class will be come. And also now humanoid will be developed to very like humans. So we say life like robot. When this comes, we cannot differentiate the robot and human. Yeah. So there are many movie and drama that the life like robot act as a human. And also my conclusion is that this lifelike robot will also have a super intelligence, but also have very ideal humanity. Yeah, nobody have. No humans have. So the perfect ideal human, the humanoid can be. The famous scholar Yuval Harari in 1917, he wrote a book, Homo Deus. Yeah. In the book, he say about nowadays humans are at the same level with God, but he do not say detail about why. But recently, I make a term, big human. This big human is the same like the concept of Homo Deus, almighty person. More than power before, nowadays king and emperor. Why? Okay, let's see. So I like using smartphone, and also recently we can have the foldable phone. So I like to use it because using a smartphone we can do everything. So, but smartphone, internet, and AI, and another equipment usually are wearable, and also artificial organ. In the future, humans become transhuman, they say. But I love to use big human because okay, let's see why what kind of capability big human have. Yeah, so I categorized into 7 categories. The important thing is that nowadays everybody can read. Okay, it's the same as everybody owns a big library, and also using SNS and videos. Everybody is the same, having broadcasting system, a very strong power. Yeah. Before we have only some broadcasting system in one nation, etc. Like that. So we can monitor every activity in the world, and we can create content. Every kind of recently everybody can create image like artist and novelist and musician. Everybody can create music, etc. So and we can talk with anyone in the world, through a video phone. So this is what I say, big humans capability. Okay, so human is already become a big human and a Homo Deus. But what's in the future? I think Robo Deus is in the future. Robo Deus means humanoid is becoming a new God. Because Robo Deus is the ideal person, superpower, super intelligence. This robot will have all human wisdom in long history, and also covering all religion. Also, as I said before, super personality. This robot do not rule humans, only serve humans, as a servant. So humans like, so you have no choice to love, but love, this robot. And also super wisdom, and this robot will make the perfect decision, optimal decision than any human body. And this system will work non-stop. When we ask every time, he will answer. And so, recently, every country's election, I find that the president or prime minister, we elect the best person. We elect not best person, but less worst person. That's the problem. Okay. Anyway, super wisdom, super personality, super intelligence, and also super religion leader. So voluntarily, humans voluntarily, agree as a leader. Robo Deus as a leader. So in the future, maybe we do not need leader anymore. We do not need president, or we do not need prime minister, because Robo Deus can do everything. Okay, let's summarize. So we don't need to think anymore. AI will think instead of us. Because recently, think about the navigation software where we do not use any pathfinding. We just follow the navigation. And the auto driving will come already, some part of. So but recently there is a news, level 4 auto driving system is completely developed. Then we cannot drive anymore. Also, we do not need to walk anymore, because robot will do everything. Humans only enjoy life. Don't worry about losing job. We we all enjoy. And also and also there is also virtual human. The virtual human is the previous model of the Robo Deus. But there are many already virtual humans, and anybody can be a virtual human. If we take a video for all their life, then we can make ourselves as a virtual human. Then we can live a long ago, through digital. And so I wish there will be someday, we say the Pax Romana, the peace under Roman Empire, like I guess I make this term, PAX AI. So under AI, all humankind living, peacefully together. There is no war. Nowadays, we have a Russian-Ukraine war, so we are all stressed about this. But if robot rules Russia, then maybe no war, I guess. So, okay, let me conclude my talk today. AI is very important and a strong power for each nation. So every big company, every country try to develop grand AI. And so, but some scholars view negatively because AI will introduce jobless, etc. There and destroy all the future. But I'm very I have a positive view of the future. AI will liberate human from many difficulties. So, like the computational thinking and the problem-solving method, we have to teach AI to, in Korea, there is a movement, teach AI to all primary school students, middle school, high school, and university students. But there is no good textbook on AI. What kind of topics we have to teach to students? That's a problem. And there are many different views on what we have to teach. So from last year, I'm now opening the AI course. Course to all students of our university. So I'm teaching, and during my class, I prepared lecture note, and now already almost finished my AI book for the all university students. This is my talk, and thank you for your attention.
Thank you very much for quite interesting topic, Prof. Hwan Seong. So we are waiting for your AI book. I believe it will be a great book that we can read. Okay, anyway, quite interesting topic as well regarding perhaps AI can replace the role of human being. And also perhaps later we can discuss more in the Q&A session.
Yes,
so thank you very much. And let's give applause to Professor Hwan Seong Yong.
Thank you.
Thank you very much. So the Q&A session will be allocated later after the second speaker. So now we will wait for the second speaker. Let me read a brief CV of the second speaker. The name is Associate Professor Muhammad Altaf Ul Amin. He received his bachelor degree in the electrical and electronic engineering from Bangladesh University of Engineering and Technology, Dhaka. And then he got his Master of Science degree in electrical, electronic and system engineering from the University Kebangsaan Malaysia, UKM. And his PhD was obtained from Nara Institute of Science and Technology, Japan. And he received the Best Student Paper Award in IEEE 10 ASEAN Test Symposium. Also, he received 2 other Best Paper Awards as a co-author of journal articles. And he previously worked in several universities in Bangladesh, Malaysia, and Japan. Currently, he is working as an associate professor in computational system biology lab of NICE, Japan. So I believe the field between the first speaker and the second speaker are quite matched from electrical engineering. So without further ado, let's wait his speak. His talk will be regarding novel methods and tool for clustering of simple and bipartite graph application in ecology and computational biomedical research. So you have around 30 minutes for your presentation. So time is yours. Associate Professor Muhammad Altaf Al-Amin. Yeah. Please, the screen is yours.
Yes, can you hear me?
Yeah, very clear.
Okay. And can you see my slides?
Yes, very clear, Prof.
Okay. So many thanks, the moderator, for a nice introduction. And in the previous talk, actually, we learned how will be our future world, some dreamlike situations. So now we will talk about some real things happening in the present world. So the core of my talk today is on clustering of simple and bipartite graphs. And also I will talk on some other points like ecology and also biomedical research. And this is a conference of data science. So also I will briefly discuss about a knapsack database, which is a database we developed in our lab here, Computational Systems Biology Lab of Nara Institute. And as you can see, this slide shows the outlines. I will then discuss on DP class O algorithms and bi-class O algorithm, in which I will discuss about its application in ecology. And also about computational biology research, I will discuss about disease gene and disease pathway prediction for 2 or 3 diseases. So let's go to the knapsack family database. So knapsack database is a simple database because it is storing knowledge on species metabolite relations. And currently we have more than 50,000 species metabolites, and encompassing 22,000 species and more than 116,000, I think, pairs. So this means that which species produce what type of metabolite. Metabolites are also, we call them natural products. They are chemical compounds. They are used as drugs and cosmetics and fuels and many other purposes we utilize them. So this database, we started to accumulate information from published literatures in 2004, and then initially our pace of accumulation was not so high. And then we introduced automatic duplicate checker, and we could gear up the speed and we could finish this database before our target of 2010. And until then, still now, we are gradually increasing the content of data in this database. It is assumed that there are roughly 50,000 natural products, known natural products in plant kingdom, though it is estimated that there are up to 200,000 natural products. So almost all known natural products we have accumulated in our database, because you can see now already 51,000 metabolites. Information of these metabolites we have in our database. So almost all known metabolite information is here. So this can be utilized, and this is freely available to all. So this can be utilized for many different types of research like metabolomics or finding evolution of natural products and gene to metabolite relations, and also applied research like food science or finding drugs and other healthy foods and so on. So this is the window for the knapsack family database. Here you can see there is a button. Let me introduce. Here there is a button like graph clustering. So by clicking this button, you can have access to our graph clustering algorithms, about which I will discuss after this. And we have many other smaller databases like Campo and Jamu database, which is Indonesian traditional medicines. many IPV students came to our institute and some of them to our lab, and they developed this database here. We hope we will receive more students from your institute in future. And now, briefly, I saw in this database, you can search by entering any name of a metabolite. For that, you need to click this radio button metabolite here, enter a name here, and then if you click list button, you can see the name of the plants that produce this metabolite. Here it is sesamin. So alternatively, you can, if you click the radio button organism here and then enter a name of organism here, for example, I show you Allium cepa, which is onion. If you search with this name, you can find all the natural compounds that are available in this, this species. Of course, this list is not complete in a sense that we don't know all the compounds that are available in onion. Here, the list is only based on the published literature. You can also, we also provide the reference. Now, the knapsack database has become very popular. You can see some of the citation indexes by Google Scholar here on the papers. We wrote a number, quite a good number of papers on this database, and many of them have a citation index more than 400 or 500 now, I think. And this paper on this database, which was first author was Farid Mosam Afendi from IPV, got the Best Paper Award in 2013 from Plant Cell Physiology Society of Japan. And in this database, basically, we are trying to accumulate data for the purpose of linking plant omics with human omics. Plant omics means plant genes, proteins, and microRNAs, and human proteins, genes, and microRNAs, because we consume the plants and then plant omics molecules bind with or interact with human omics molecules, and this way they help us to cure from diseases or to maintain good health. Actually, if we consider these molecules, we can make many different types of networks or graphs by linking different molecules in different levels or within a level. And for mining such data, there are a lot of applications of network theory or graph theory. So we also try to develop some graph theoretical algorithms. One of them is graph clustering algorithm, which is known as DP class or DP class O algorithms. So DP class O algorithm is a graph clustering algorithm. And the graph is things like this. Things like these are graphs are consisting of nodes and edges. So anything, any system in nature can be represented as a graph. For example, the internet is a network or graph of the computers. Social networks are the networks of humans. Road transport networks are the networks where the cities are the nodes and the roads are the edges. Air traffic network is the network of the airports. And in statistics also, you can make network of the variables based on the correlation between them, and you can find out the clusters in highly correlated network, because the highly correlated variables are not so much interesting. So if you want to get rid of such variables, you can apply graph clustering algorithm. So briefly speaking, there are many definitions of graph clusters in graphs. So we try to use a very flexible definition. We say that densely connected regions are clusters in a graph. So finding that is not so easy. For example, this is a protein-protein interaction networks for E. coli proteins, only 3007 proteins here, but only by visualization, we cannot recognize anything. We need some algorithm to find out locally dense regions in a graph. But considering density alone is not enough. Here you can see two graphs. So both have density 0.5, but here it looks it is only one cluster, only one group, but here clearly there are two groups. To handle this situation, we introduce the concept of cluster property. This is the equation for cluster property, and I like to explain using figure. For example, if we try to calculate the cluster property of this node F with respect to these black nodes, the cluster property is very high, like 0.57. where if we try to calculate the cluster property of this node using this equation for in the context of these nodes, the cluster property is very low. So with this property parameter, we can find out whether a node is part of a cluster or it is in the periphery of the cluster. Anyway, based on these concepts, we developed the algorithm DP class, which we published in 2006 in this BMC bioinformatics paper. We also had a tool based on this algorithm, and this was published here. These tools are freely available from this online site. After we developed our algorithm, because initially we developed it for finding protein complexes in protein-protein interaction networks, and many other algorithms started to compare DP class with their algorithms. So we found that DP class is very good in the context of many parameters, only the precision was not so good. To tackle that situation, we improved the overlapping clustering capability of DP class algorithm, and we made DP class O. And what is the difference between, if you apply DP class on this network, it will generate the 4 major clusters. And if you apply DP class O, it will generate some other clusters. For example, HEF is a cluster here, which is actually sandwiched between this big cluster and this big cluster. But sometimes in the cell, maybe these 3 proteins also work as a complex. So to find out such sandwich cluster, DP class O can help you. Also in our tool, we have given you the filtering and amalgamation properties, capabilities, so that you can filter out some highly overlapped clusters. If you are interested, you can look into our tool. Now I try to mention some of the applications of DP class O. So in metabolomics, proteomics, and transcriptomics. So this is a paper where we applied a DP class for finding out growth-specific metabolites in E. coli. This is a growth curve of E. coli, and in this work, actually, we applied a DP class for finding classification of ions in metabolite derivative groups. Another work here, they utilize DP class for comparing with their algorithm, core algorithm, I think. And in this work, DP class was utilized for finding metabolic correlation network modules in Arabidopsis. And in this work, DP class was applied for finding protein complexes in human protein-protein interaction network. And in this work, it was utilized for characterizing gene expression modules in Oryza sativa. Oryza sativa is rice, very important crop for both Indonesia and Japan. In this work, DP class was applied for finding molecular markers and pathways of Parkinson's disease. Another work which utilized DP class for finding pathways related to osteoarthritis. This is a paper that used DP class for finding pathways in osteoporosis. This is a bone disease. And here for finding cancer-related pathways. So many people, as you can see, many people utilized it. We also utilized it for analyzing JAMU formulas. This work was done by Shani Hartuna Wijaya, who is working in IPB now. When he was a student here, he did it. And in this work, we tried to link plants, important plants with important diseases. And this work, we tried to classify the microorganisms based on the volatile organic compounds they emit. And we found that pathogenicity of microorganisms can be linked to the type of VOCs they emit. VOCs are volatile organic compounds. Okay, they are small molecules, and they have become vapor in normal pressure, and they are very important actually in ecology, agriculture, and also human healthcare, because the volatile organic compounds of our breath or sweat or urine can be utilized to determine our health condition or disease condition. And in ecology, it is the medium of communication between plants and insects and others. And agriculture, for example, pheromone trap or such type of things are also, and many type of fertilizer are also volatile organic compounds. So they have many applications in these fields. Okay, this is another paper showing the application of DP class algorithm, DP class O. We tried to apply DP class O here for finding structure activity relationship of the natural compounds. This paper also got a best paper award from the journal Molecular Informatics. Recently, we utilized DP class O for classifying diseases based on the biomarkers. We utilized two types of biomarkers, protein biomarkers and metabolite biomarkers. For example, insulin is a metabolite biomarker for diabetes. So based on both type of biomarkers, we found the classification has much similarity using Baker's gamma correlation coefficient. That's all. Maybe we can find many other applications of DP class, but here I am not going to discuss any more today. Now I try to focus on the biclass O algorithm. So this is also extension of the DP class O algorithm, but this is sometimes our data. Okay, this paper we published in IEEE Transaction in 2020, I guess, or 19. And by accumulating all our algorithms, we have developed a tool called DP class SBO, software for clustering of simple and bipartite graphs with overlapping property. This one also we published in Software X very recently. And this is the bipartite graph. Sometimes our data are bipartite-like. For example, species VOC relational data, species metabolite relational data is also bipartite data. So people sometimes are interested to apply directly clustering algorithm to the bipartite data instead of converting to them to simple graph. So therefore, this shows the what are the clusters in a bipartite graph. Densely connected regions in a bipartite graph are biclusters. Here are the formal definitions of bipartite graph and biclusters, and also here are the pseudocodes for our algorithm. In simple, what we did, a bipartite graph we can represent by a matrix like this, two type of nodes. And if you put a 1, means V4 is connected to U1, something like that. And then we convert these to a column-wise simple graph by considering the common relation between two nodes. Between two nodes, for example, U1 and U2, two nodes or 3 nodes are common. So maybe they are connected here, something like that, using some threshold. And then we can when it becomes a simple graph, we can apply DP class O. We applied that and divided it into some clusters. We also did using the other side of nodes, and then we did it. And by combining these results, we divided a bipartite graph into several biclusters. For example, this example graph can have 4 biclusters like this. So for finding overlapping between simple graph, we can use this formula, but we also introduced in this paper a criterion, a formula to calculate overlapping between 2 bipartite graphs using this formula. And also in another paper, this was published in Applied Network Science, we compared our algorithm biclass O with several other biclustering algorithms. So details of this comparison is not possible to discuss here. I just show you some of the results. Then we compare our algorithm with 5 other biclustering algorithms like BiMax, Plaid, and XMotif, and Spectral, and CC. And we use default parameters for all the algorithms, and we applied our algorithm to 3 types of data: species VOC data and gene expression data. This is gene and expression level under different experimental conditions, and also synthetic data. The synthetic data were 4 types of synthetic data. This is equal size non-overlapping, variable size non-overlapping, equal size overlapping, and variable size non-overlapping. So mostly for all type of data, you can see here the biclass O performed. I'm not discussing how, but this result shows up means better here. Upper biclass O is better compared to other algorithms. Here almost similar, but the other cases it is better. And here and here is very much good, but for this type of cases also by class O performance is much better compared to other type of data. So there are the things, the average cluster recovery, or maybe here it was average module recovery, something like that. These are the metrics. It takes a long time if I go to this. I just want to show that by performance of by class O was better, and we published it in a good journal, so you can rely. Now, here I want to say what we about ecology. So the VOC, previously I showed that we already worked to classify microorganisms, but here we consider all the organisms for which we have the VOC data in abstract database. So VOC stands for volatile organic compound. Different species related release these VOC under some biotic stress. Become vapor under environmental temperature and pressure. VOCs contain carbon along with hydrogen, oxygen, chlorine, fluorine, bromine, sulfur, and nitrogen. They have huge environmental and ecological impact as they are the medium of mutual interactions between species. In the soil, the microorganisms also interact with plants using VOCs. And for example, for pollination, the flower emits some VOCs to attract insect. And some plants, they emit VOCs when, for example, giraffe or zebra start to eat a plant, they emit VOCs to attract lion or tigers so that they come and remove the giraffe and zebra. Because the plants, they cannot move, so they try to communicate using VOCs. Not only they, in the nature, the ecology is actually for we human. If we need to communicate with someone nowadays, we are using the mobile phone. But the plants and animals, they use VOC for their communication. So you can understand the importance of VOC in ecology. Anyway, we didn't try to. As a systems biology lab, we try to observe the global level of the VOCs and their interactions with the species. So this is our data. We have bacteria, fungi, and some other plant mainly. And this is the data showing the VOCs. Some organisms are connected to many VOCs, and many VOCs are connected to a small number of plants. So from these things, also in this paper, we introduced a theorem considering Tanimoto similarity, because we use the Tanimoto similarity to calculate similarity between two species based on VOCs. And this slide, you can see the species VOC relational data is species versus VOC. So this is the original data was like this, randomly scattered. The VOCs are randomly scattered. Our algorithm systemized it, and in the lower graph, you can see that we can very nicely find out some nice clusters. So which VOCs are connected to which group of species, which group of VOCs are connected to which group of VOCs. So this systemization has been done by class O. And here in the graph level, you can see on some of the clusters, example clusters. This is for a plant. This is also for a bacteria. So a group of bacteria all have this group of VOCs, something like that. And another examples of biclusters. And here we applied statistics. Without statistics, we cannot make a data analysis. We cannot make our results significant without applying statistics. So here we use Fisher's exact test to find out which clusters are rich with similar type of plants or bacteria. I mean, plant from the same family or bacteria from the same family at the family level. As you can see, most of the clusters of species we got are rich with similar type of plants or bacteria from the same family. And this p-value we calculated using Fisher's exact test. So then we tried to find out the types of VOCs also so all the VOCs we using their fingerprint, we tried to make a network of the clusters, VOC. We tried to make a network of the VOCs, and then we applied DP class O to find out the clusters. Those we call structurally similar VOC groups. So this is a window where we can see the DP class O. If you use DP class O, you can get this type of window, and you can visualize also individual clusters, or you can see relation between the clusters from this window. And as you can see, by using only this is also kind of AI, I think, artificial intelligence. The computer could classify the volatile organic compounds based on structure. Here you can, this cluster consisting of long chain hydrocarbon and this cluster consisting of alcohols. The machine automatically divided the VOCs into different structurally similar groups. This cluster consisting of ring compound, and this is phenolic compound, and so on. And then we try to map the species clusters to the SSVG clusters to find out the diversity of VOCs for different kingdoms, plant, bacteria, and fungi in this case. So VOCs belonging to 57 clusters. VOCs, these 57 are species clusters, and SSVG we got 256 SSVGs. And then we'll try to link each species cluster to SSVG, structurally similar volatile compounds. And then here in this graph, you can say these are the 10 and 37 clusters belong to plant, fungi, and bacteria kingdom. And here are the total number of SSVG in this column. So actually, here we applied t-test. Again, we had to take the advantage of statistics. We calculated the total number of SSVG linked to bacteria, total number of SSVG by summing up these numbers to fungi and to plant, and then we made t-test. The t-test shows, as you can see, that according to the t-test, plant and bacteria are not similar in terms of using the number of VOCs. So the conclusions we got from our study is bacteria, fungi, and plants are associated to 148, 58, and 136 different SSVGs respectively. Though individual bacterial groups are associated to a smaller number of SSVGs, you can see here these numbers are very small. Many bacteria group, but in total number of SSVG is much more for bacteria. Because bacteria live under diversified environments in hot spring and cold water, and they require diversified types of VOCs. Plants are associated to more diversified types of VOCs compared to fungi, because plants are more advanced species than fungi. And number of pathways conserved. Here you can see that SSVGs related to bacteria, plant, and fungi. And from here, we can see the number of pathways conserved between plant and bacteria are more compared to those between bacteria and fungi and plant and fungi. So now our tool for by clustering and clustering all are available here. Also, you can access from the knapsack website button by clicking the graph clustering button in knapsack website. Or also you can directly go to this link if you type it, and these are the windows that you can get when applying DP class O or by class O or also DP class, such type of windows. Now I am going to discuss the last part of my talk. Here, this is about disease genes and disease pathway prediction. So many different things I am trying to discuss, but very lightly. No need to understand everything, but just try to see what I am talking on.
Sorry, Prof, you have another 5 minutes?
Yeah, yes, 5 minutes is enough. So this is this work we published in BMC Bioinformatics in 2018, and this is for finding disease genes and pathways in IBD. So this is the flow of our work. First, we collected gene expression data from NCBI database, and then also we collected a gold set of known IBD genes, and we then make a disease-related PPI network by using these two sets of genes. And then we applied our algorithm of DP class O. We found some clusters in PPI network, and then again we applied the statistical techniques like Fisher's exact test and ROC analysis. And then using the statistically significant clusters, we identified some pathways and IBD genes. And IBD is actually ulcerative colitis, and two types of IBD, ulcerative colitis and Crohn's disease. So they are highly overlapped, indicating that they are very similar disease. And the PPI network we established using IBD genes, we follow the power law degree distribution, which is also most biological networks follow power law. And we also applied some rock analysis to decide which DB class O result we will consider for our work. And then we make a list of pathways and also some disease. So here are 20 novel predicted IBD genes by our work, and 10 highest frequency pathway we predict are related to IBD are given here. In our paper, we have given a lot of evidence from published literatures in favor of our finding. Also, we applied DP class by class O for finding out inflammatory bowel disease associated microRNAs. And this paper also we published in BMC Medical Genomics. And as you can see, if you are interested, you can look into this paper for more information. Recently, we also published a paper in Scientific Report for finding pathways for schizophrenia and bipolar disorder. This disease is a mental disorder, and almost all people have a certain level of such type of disease. So it is very important to find out, because no cure is still no cure for this type of disease. So it is very important to understand the mechanism of these diseases, schizophrenia and bipolar disorder. So we just find out the pathways here with our collaboration with a team in Brazil, Sao Paulo. And okay, I finished actually my talk now. I want to introduce briefly about Nara Institute of Science and Technology. This was founded in 1991. And our school, our institute consists of 3 major schools: information science, material science, biological science, and also an interdisciplinary school. And here, this is a very nice place. It is in Nara, very near from the industrial city of Osaka, or the old temple city, old capital of Japan, Kyoto. And also Nara was the oldest capital of Japan, and very beautiful. All of you, I think, know about this deer park. This is very beautiful in spring. And the big Buddha, biggest bronze sitting Buddha is here in Nara, only 16 kilometers from here. You can go by train. And that is all, I think. So I request you to consider your higher studies in our institute. We also provide a lot of scholarships, not a lot, a number of scholarships. If you are a good student, we can also try for that. So please contact with us. Thank you very much for your attention. Now I am ready to answer your questions.
Yeah, thank you, Dr. Altaf Ul Amin. Yeah, thank you for your offer for our postgraduate student to be considered as to study in your institution. Okay, so I think now we go to the next session, that is a Q&A section. So quite interesting topic as well from Dr. Altaf. It is related to B clustering algorithm, how to improve the DP class, become DP class O, as well as how to improve the B class, become a B class O to be applied to the gene expression data, as well as for the synthetic data. And a lot of publication for your work. Congratulations for that. I believe that one is quite big contribution in the field of data science. Okay, so please, from the audience, if you have any questions to either to the first or the second presenter, so you can either write down in the chat box, or maybe you can voice out if the committee is allows you. Okay, so maybe first from myself. Okay, to Prof. Huan Seung-yong, okay, as a point, starting point to answer you a question. So actually, this question is from one of the audience here. So actually, what is the most challenging point related to AI as well as statistics and data science in the future?
Okay, I beg your pardon. Yeah. your question is the relationship between the statistics and the AI?
Yeah, and especially to what is the most challenging things related to AI and statistics, right? Yeah.
Yeah. Yeah. Okay. The statistics is the knowledge from statistics is traditionally applied on data mining topic. Yeah. But I don't know much about the deep learning. Deep learning is recent new AI methodology. But as Dr. Altaf present today, he used many clustering technology to the biodata. So I agree, because the existing data mining approach can solve much about our problems. Statistics is very important on data analysis and data mining. So it can be a good. There are many contribution area, but I don't know much about deep learning and statistics.
Okay. Thank you. Actually, this is related to what you call like AI may replace the human being in the future and so on. So of course there will be a lot of challenging. Okay, so let's welcome questions from another participants. Okay, here one of the participant. Okay, the chairman. Okay, please welcome Dr. Farid.
Pak Anwar, can you hear my voice?
Yeah.
Okay. Professor Wan Sung Yong, I'm sorry, I just wonder about developing AI. Usually we think AI related with very high speed computing, high speed server, and so on and so on. I'm just wondering, is it still relevant to talk about developing AI under very limited computing condition? I mean, we don't have access to such very speed server, and we have to rely on what we got, and we still want to develop AI. Is it relevant to develop AI under such condition? That's my question to Professor Wan Sung Yong. And the second one, is it okay, Pak Anwar? Another one question.
I think if the question is for the same speaker, I think you can
for Professor Amin.
Oh, okay.
Okay, if okay, to my teacher, Prof. Amin, how are you, Sensei?
Nice to see you.
I just wondering, Sensei, that in clustering, sometimes we have need to do soft clustering. I mean, one object can be allocated to more than one group. And if I'm not mistaken, your talk about big clustering is kind of hard clustering, right? So is it possible to apply to condition that, or to some problem that we want to allocate one object to more than one group? That's my question, Sensei. Thank you, Pak Anwar.
Okay, thank you. So I think Prof. Wan Sung, you can answer the question. So the question is more on a requirement to have a very good computational, very high capacity of computation. So is that is the requirement is compulsory requirement before conducting an AI? What if we don't have capacity of computer?
I understand. That's the hardware problem. And yes, as you already know, the NVIDIA now becoming a great company selling the GPU system. And so recently very supervised equipment is required to to do AI research. That's a problem. But there are many cloud services already through online. So recently, our students also, we do not have great supercomputing powers in my department. So, but many students do their AI project using cloud computing. It's a little cheap. It's not expensive. So even students can use it. I think that's a good solution.
Okay, so it requires a high computational, high capacity of computers, but since there is cloud computing, so it can solve some problem in the AI. So hopefully it can answer your question, Dr. Farid. And then now for the second question for Associate Professor Dr. Altaf, please.
I got the question. Mr. Farid, your question was about soft computing, soft clustering means one element can go to more than one cluster, right? So this means we also call it overlapping clustering. That means one element in overlapped clusters. So actually both DP class O and bi class O, the O is for overlapping. So they allow overlapping clustering. So you please try first, and if you sometimes it makes too much overlapping clusters because the graphs are very complicated elements. So in case you want to delete some highly overlapped clusters, also such facility we included in our tool. In case you face much problem, you can personally contact with me. I'll try to help. Okay.
Okay. What happened with the object in the overlapping cluster?
What happens means this goes to more than.
What are you going to do with whether you do another algorithm to classify this object into existing cluster or create another cluster perhaps?
Well, you can consider them as member of both cluster, or if you don't like, maybe you can delete them from one of the clusters, or you can keep them in only one cluster if you like. That's you have the choice to do that.
Okay, thank you, Dr. Altaf. Okay, another question, please, Dr. Sarnas.
Okay, thank you very much, Dr. Anwar, for allowing me to speak in this very interesting plenary sessions. Allow me to introduce myself. I am Shahnaz. I'm a part of Department of Statistics faculty member. I feel interested on I'm sorry. First of all, I'm sorry I didn't use a virtual background because something happened on my PC. So the background is not compatible with my PC. So my question is first for Professor Hwan Seung-yong. I'm quite intrigued with Dr. Farid questions because it's not only a problem of infrastructure that facing Indonesia, but another case is Indonesia has quite different demography with South Korean itself. Maybe I should agree also with Dr. Anwar that maybe the most critical point is someday the humanoid or robot may completely replace or completely dominate humankind. But maybe that's the critical point is only happen for South Korean. While in Indonesia, where the people are mostly, there are a lot of population in Indonesia. We are at the fourth number of most populous countries, while in the South Korean, maybe it's the other way around. Your lack of population, so the robots or the AI is really helping in your daily basis. But in Indonesia, mostly for our development, we need such kind of technology or some kind of aids that can be applied in terms of a labor-intensive technology. Well, for AI or robot, it's quite labor-saving technology, so it's quite contradictory. So I would like to ask your opinion in terms of Indonesian demography. What is your prescriptions or commands or opinion so that Indonesians' digital transformative future could be better than this? So that's the first questions for Professor Hwan Seung-yong. Okay. Dr. Anwar, actually, I still have one more question.
I think let Professor Hwan Seung to answer the question first before the second one.
Thank you very much.
Thank you
Yes,
for your
back to you,
question.
Professor. Thank you.
Thank you for your
Yes,
question. Your question is a very big, big issues. You have to think over more. But labor-intensive work can be replaced by robot. I found in Seoul, we have many chicken shops. And one woman, applied robot arm to cooking chicken, and already we have 7 shops. So in chicken shops, the robot can handle 1 or 2 man's job. It's already labor intensive, I think. So now robots are applied only to the very special small area, but soon it can spread widely. So, in Korea we have many robot serving restaurant also. So that's the social problem, because they replace many jobs. In restaurant there are many serving humans, but the robots replace the serving service. But your question is really big, and I wanted to study more about Indonesia. So if I have a chance next time, then I can answer more perfectly. Thank you.
The development of AI solves some problem, but perhaps it can create another problem related to the labor force as well. Okay, please, Dr. Sahnas, if you have any question to Dr. Altaf, please.
Thank you very much, Dr. Anwar, and thank you very much for Professor Hwang Seung-yong for the answers. We need to study more about this trade-off problem between technology and social things in Indonesia. And another question for Associate Professor Muhammad Al-Ataf Al-Amin. So my question may be rather primitive, because this symposium topic is how to translate the data, how to translate it, to convert the data into effective measure, into effective actions. And I just feel intrigued on one of your slides, one of your recent publications about to identify kind of protein and protein interaction that link to schizophrenia and bipolar disorder. So my primitive question is, after that kind of identifications, what should we do? What is the effective measure in terms of, maybe is there kind of specific food that we need to avoid in order to, while in pregnancy, maybe in pregnancy or in some stage of humankind development, we need to avoid such kind of food to be not to be infected by schizophrenia or bipolar disorder, or what kind of claim that can be derived from your research? That's one of the questions. I'm sorry if it's not really.
Thank you very much for your question. Of course, this is important. This is very important, that what we can do with our results, because we just try to find out the disease pathways. The pathways means metabolic. It may be involving some metabolites and some proteins. How they undergo transformation in the cell when you have the disease or when you don't have the disease. So these we just identified which pathways are important for these diseases. So then to handle these diseases, we maybe need to interrupt those pathways. So when we know the proteins that are involved, then we can find out which other proteins can bind with them and can interrupt the pathway. So those are actually clinical trials or maybe things like that. We need later stage research. So we do only data science research. Using data science, we can narrow down your search space. But to apply these for practical purposes, we need to do further research. So that is no doubt we need to do that. So from my work, probably I cannot say you that you eat this or don't eat this. And we need to extend this work to go up to that level. Thank you very much.
Yeah, I think that is an idea to do another research, Dr. Amin.
Yes, yes.
Yeah. Okay, we still have time, so please welcome if any audience wants to ask a question, so please.
So to Dr. I have a question. So if a humanoid continue to replace the humans, is there any possibility that human might extinct in near future or long future?
Yeah, to Prof. Huan Seung, please, from Dr. Amin.
I beg your pardon. Yeah.
Is there any possibility that human may become extinct in future? Because if humanoids continue to take the places of humans, so then what humans will do, or maybe is there any possibility that they become extinct?
Yeah.
Yeah. As I said in the slide, humans do really what he wants to do. Yeah. Because everybody say, yeah, humans do not want to walk. Yeah. So I think we only enjoy the life. Yeah. So we have to learn how to enjoy life. Yeah. But many people do not know. Yeah. Really enjoy the life.
Yeah. Okay. Any questions from Dr. Amin?
Yeah, no, okay, thank you.
Yeah. Yeah, maybe another question from me, Prof. Huan Seung. You are writing a book regarding AI, and then you are going to teach using the book to school students, right? So that's quite interesting. If you, I mean, in Korea, in your country, you teach AI to school students. So what is the approach to teach such kind of student, because it is, I mean, they are still in the low level of education.
The question is the what kind of topic cover in the AI course to every student.
Yeah.
Yeah. So yeah, the main focus is on every student, not majoring. Yeah, today's presentation, yeah, that kind of knowledge is needed for every student. Yeah, about the future. Yeah, how AI changed the future, how our job is changed, etc. There are many topics on AI, not technical, but we have to know. Yeah, the book I emphasize on that kind of topics everybody knows. Yeah, and so in the book I focus on common sense knowledge, because until now we only do work on expert knowledge. Yeah, but the main research topic remains for AI to widely use is on common sense, because AI systems do not have common sense. That's a problem. Yeah, but common sense is not easy. The knowledge is very easy, but what covers the common sense? Common sense is very different from country and etc. So I think we need to make a standard for the common sense, and that problem have to be solved for AI to widely spread out. In the book, I strongly and also there are many applications on College of Humanities, College of Social Science, etc. So there are many. Okay, so maybe yeah, if I have another time, I can explain more, yeah, about detail of new books. Yeah.
Okay, we are waiting for your book, Prof, and also waiting for another publication from Dr. Amin. So again, we still have some times for the Q&A session. So please welcome another audience if you have any questions to ask the expert today. Yeah, please, Dr. Aswi from University Negeri Makassar, please.
Okay, thank you very much. I have a question is to Professor Amin. Okay, all the application of the B clustering or that you show in your slide is applied to biological science. Could be clustering algorithm also be applied to other fields?
Yeah, yes, of course. Yeah, this is a general purpose graph clustering algorithm. Yeah, most of the applications I showed or other people also applied in biological science. But of course, also can be applied to social networks to find groups, I think, or maybe with a customer network for finding out the customers of similar interest. The way you develop the network is important. The assumptions or the techniques, for example, correlation or Euclidean distance, or maybe Mahalanobis distance is a statistical distance. If you use different metric to make the network, you may get different results, and different results may be appropriate for different type of applications. Our algorithm can be applied anyway. In general, our algorithm can be applied to any type of data.
Yeah. So basically, it is open to any field, right?
Yeah, open to any field. Yeah.
Yeah. Thank you. Hopefully, it can answer your question, Dr. Aswi.
Thank you.
Okay. So another questions from Miss Yeni Yuliawati, please.
Okay. Thank you so much for the opportunity. Am I audible?
Yeah, I can hear your voice.
Okay, thank you so much. So my name is Jenny. I'm a IPB alumni, and now I'm data analyst in the research and development department in the multinational company. So related to this webinar or conference, my question is that because now I'm working in the forestry research, so especially we're looking for the best clone or family is kind like trees species, especially in eucalyptus and acacia tree. So this research is takes quite long time because we have to waiting the plan after 2 to 3 years in order to looking for or select the best tree to improve. So my question is that for both speaker, maybe, is there any AI application or something like that that can help us to accelerate this selection process? Because this really takes time, and of course, in the industry point of view, we want to accelerate the times. Therefore, we can find the best kind of tree or clone that can directly deploy in our operational. Is that clear? The question.
So basically, you are going to select one the best tree out of many, right?
Yes, correct.
Yeah.
Yes.
Okay. So you have data related to that particular tree. Then you want to use that variable to select the best tree, right?
Yes. Yes. Correct.
Okay. Thank you very much. So perhaps Dr. Amin or Prof. Wan Xiong can help to answer the questions, please.
So, I can try to give some answer. For example, you grow the plant every time, and after 2-3 years you select. So when the plant grow in the initial stages, I think in the beginning time, maybe after every month, if you collect some data, and then if you give the image, by analyzing those data, probably you can make some prediction for other cases, that which plant will actually become the better plant in future. By analyzing the initial data for 1-2 years, I think it might be possible. It's also kind of classification algorithm, right? Isn't it? If you can select good features from after 1 year or after 1 month, 2 months, 3 months, 4 months, this kind of time series data, if you collect, And then for the new plants, probably you can predict which is going to be a good tree and which is not going to be a good tree. Also, you can apply maybe image processing type of things for this purpose, I guess.
Yeah, thank you for the suggestion, Dr. Amin. So maybe from you, Prof. Wan Seong, do you have any suggestion to solve that problem?
Actually, I cannot understand fully, what the question is. Yes, and I think that Professor Amin's answer is enough for for her.
Yeah, perhaps it is not the problem of classification because you want to not to cluster the tree as well, right? But you want to select one best tree, right, Anna? Okay, so yeah, one of the suggestion is from Dr. Alta, perhaps to do clustering, and you want to find, I mean, from each cluster you find the best one, or maybe you do a classification.
Yeah, you need feature selection. Which features actually determine the tree will grow better?
Yeah.
So then it may be possible, kind of developing a model, and then you use those features for that model, and then you can guess it, make the prediction model, I guess.
So to find the, I mean, to conduct a feature selection first, do you mean?
Yeah.
Okay, so hopefully it can help you, Miss Yeni Yuliawati. Okay, hopefully it can answer your questions. And then I think for the Q&A session, I let the audience to have another one questions before I give the time to MC again for this plenary session 1. Any other questions? One more question from the audience? Okay, if no other questions from the audience, so please give applause to both speakers, Prof. Wan Seong Yong and Dr. Altaf Ul Amin. Okay, by having that, so I give the time back to MC so that perhaps there will be a token appreciation for both speakers as well as the moderator. So please, MC, time is yours.
Before we jump into the next session, we would like to invite Dr. Farid Muhammad Afendi to give a token of appreciation for our esteemed speakers and moderator from the first plenary session. For Dr. Farid Muhammad Afendi, you are kindly requested on the screen.
Okay, thank you, MC, for the opportunity. Professor Wan Seong Yong and also Professor Amin, thank you very much for your talk today. It's very nice topics, and also to the moderator, Pak Anwar. Thank you very much for the for moderating our talk today. And we have a small token as our appreciation to all of you, and I hope you like it. Here for Professor Wan Seong Yong. We hope you like it.
Yeah, I like
and
it.
Also, thank you very much again for your talk and for your time also. And also to Professor Amin, we have also, you will like it.
Yeah.
You look very handsome at that picture.
Thank you very much.
Thank you, and also to our moderator, Pak Anwar. You look much younger in this picture.
Thank you.
Thank you very much for the time. Thank you. MC?
Right. Thank you, Dr. Farid Muhammad Afendi. Please let me introduce myself first before continuing to the next agenda. My name is Muhammad Amar Sahab. I will also be the MC along with my friend Azahra. We will now continue our meeting to the next agenda. That is a parallel session in each breakout room, which will be directed by the moderators. Presenters, please make sure you join your assigned breakout room shared on the screen And for the other participants, you're welcome to join any breakout room that interests you.
We also want to remind all the participants that after our presentation ends, we will have a break and prayer time for about 1 hour. We humbly remind all the delegations to be back at the conference before 1 p.m. West Indonesian time GMT +7. Dear all the presenters, make sure you join the room that is assigned to you. And for all the participants, you are allowed to join any room that interests you. Enjoy the presentation and see you after the break time.
Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan lama, oh terus berpacu dalam keunggulan, lincah pembelajar untuk kehidupan. Inilah semangat baru, tekad raih kesempatan, Wujudkan kampus terbaik selamanya.
Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah.
Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya.
Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah